Chemistry for Neet. Today's topic is hybridization. Now, what is hybridization? The simple meaning of hybridization is mixing. Okay, if you mix 1 spoon of sugar with 3 spoons of salt, then what will you get? You will get a mixture of total how many spoons? Total mixture? That is 4. 4 spoons of mixture. If the mixing is homogeneous is equal in every part, then what will be the ratio of each spoon of this mixture? There must be 1 part of sugar and 3 parts of salts. So the ratio in each mixture of spoon is 1:3 of salt and of course of sugar and salt. Sugar and salt will be 1:3. Now the concept is in the formation of a covalent compound, at first a necessary rearrangement occurs in the outermost shell or valence shell of the central atom. That means, let us consider the formation of methane molecule CH4. Now, carbon has already made 4 covalent bonds. So, carbon should have 4 unpaired electrons in its outermost shell. Now, the electronic configuration of carbon is, carbon has the atomic number of 6. So, the electronic configuration is 1s2, 2s2 and 2p2. So, the outermost shell is second shell and the total number of electrons present in the second shell is 4. Now, in 2s orbital, paired electron pair is present, and in 2p orbital 2 unpaired electrons are present. Now, since carbon has already made 4 covalent bonds, therefore carbon should have 4 unpaired electrons in its outermost shell or valence shell. So, here we can see only 2 unpaired electrons are present. So, a rearrangement occurs where an electron jumps from 2s orbital to 2p orbital, giving rise of 4 unpaired electrons. Okay? So, this is the first step for the formation of a covalent molecule. In the first step, a necessary rearrangement occurs in the outermost shell of the central atom. Here carbon had 2 here 2s2 and 2p2. The rearrangement is an electron jumps from 2s orbital to 2p orbital, giving rise of 4 unpaired electrons. Now, the next step is the mixing of orbitals. Okay, here you can see 1 spoon of sugar and 3 spoons of salt, giving rise of 4 spoons of mixture, and if the mixture is homogeneous, then each spoon of that mixture should have sugar salt ratio of 1:3. Similarly, here a mixing occurs among the outermost shell where the outermost orbitals where the unpaired electrons are present. Now, here with 1s orbital, 3 p orbitals px, py and pz. With 1s orbital, 3, this is not 1s, this is 1 s orbital and 3 p orbitals. Mixing occurs between one is s orbital and 3 p orbitals. So the mixed orbital, number of mixed orbitals, that must be 1 plus 3 4, and each orbital, since the mixing is homogeneous, each mixed orbital should contain one part of s and 3 parts of p. Therefore, the state of hybridization is sp3. When one s orbital is hybridized with 3 p orbitals, then the state of hybridization is sp3. So here we get 4 sp3 hybridized orbital in methane. Now those 4 sp3 hybridized orbitals, the next step of the formation of a covalent molecule is those hybridized orbitals will expose themselves around the central atom in a definite manner depending upon the state of hybridization. Now Mrinmoy is present here. Hi sir. Hello dear. Now 4 sp3 hybridized orbitals will expose themselves around the central atom carbon in a definite manner depending upon the state of hybridization. If the state of hybridization is sp3, then we have to remember that then 4 sp3 hybridized orbitals will tetrahedrally expose themselves around the central atom carbon. Okay, so these are sp3 hybridized orbitals which are placed around the carbon, central atom carbon, in a tetrahedral manner. Now the atomic orbital of hydrogen comes with a single electron which is present in 1s orbital. Okay, and here an overlapping occurs between 1s orbital of hydrogen and sp3 hybridized orbital of carbon. Here again another hydrogen, 1s orbital of another hydrogen comes. Here 1s orbital of another hydrogen, and here 1s orbital of another hydrogen. So here overlapping occurs, 4 overlapping occurs between sp3 orbital of carbon and s orbital of hydrogen. That is how CH4 is formed. Okay, that is how CH4 is formed. Now if we join this, we get a shape of tetrahedral. This shape is called tetrahedral. Now we can also draw this in this manner: hydrogen, 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 and here hydrogen. Okay, this is a tetrahedral molecule. Methane is a tetrahedral molecule, and each bond angle means the bond between the angle between two bonds, that is this angle is 109 degree 28 minute. Okay, 109 degree 28 minute. For sp3 hybridization, the bond angle is 109 degree 28 minute. This is methane is a perfect tetrahedral, and the each bond angle of methane is 109 degree 28 minute. Next we will see the state of hybridization of sp2. The molecule where sp hybridization occurs is say boron trifluoride. Now let's see how boron trifluoride or BF3 is formed. Okay, now boron, what is the atomic number of boron? Hydrogen, helium, lithium, beryllium, then comes boron. So the atomic number of boron is 5. So its electronic configuration must be 1s2, 2s2 and 2p1. Okay, now 2s orbital, paired electrons present in 2s orbital, and in 2p orbital, p orbitals, 3p orbitals, among them only one unpaired electron is present. That is, so this is the valence shell or outermost shell of boron. Now here only one unpaired electron is present, but we are going to make the formation of BF3. So in BF3, boron has already made 3 covalent bonds, 3 single bonds. Therefore, boron should have 3 unpaired electrons in its outermost shell. So here a necessary rearrangement occurs when one electron from 2s orbital jumps to the 2p orbital. Okay, from 2s orbital jumps to the 2p orbital. So the rearranged configuration is one electron, only one unpaired electron present in 2s orbital and two unpaired electrons are present in 2p orbital. Here we have a total of 3 unpaired electrons in boron in the outermost shell or valence shell of the central atom boron. Okay, now hybridization occurs among the orbitals where unpaired electrons are present. So with one s orbital and two p orbitals, the mixing will occur, that is hybridization will occur, and each hybridized orbital will have one part of s orbital and two parts of p orbital. Okay, so hybridization occurs between these orbitals, and the state of hybridization between one s orbital and two p orbitals. So the state of hybridization is sp2. And how many sp2 hybridized orbital will be there? Of course 3. So 3 sp2 hybridized orbitals will be formed. Now after formation of this 3 sp2 hybridized orbitals, this sp2 hybridized orbital will expose themselves around the central atom boron. Okay, now in which manner? It will depend upon the state of hybridization. Okay, if the state of hybridization is sp2, then those 3 sp2 hybridized orbitals of boron will expose themselves in trigonal planar shape. Okay, so here is boron, trigonal planar shape. Here is one sp2 hybridized orbital, here one sp2 hybridized orbital, and this one is the other sp2 hybridized orbitals. Now fluorine comes with its outermost orbital where unpaired electron is present, and overlapping occurs here, here and here. So these are the fluorine atoms 1, 2 and 3. Here overlapping occurs, and the shape is, if you outline this, draw the outline, the shape will be trigonal planar shape. Okay, so if the state of hybridization is sp2, the shape is trigonal planar. That is, all those 3 hybridized orbital will lie on the same plane. That is, here is boron, here is one fluorine, another and another. And if you draw this will be a tetrahedra. This will be the trigonal planar shape, and the bond angle, that must be all are on the same plane. Okay, the total angle is 360 degree, and if you divide this by 3, then each bond angle will be 120 degree. So the bond angle for trigonal planar shape, bond angle for trigonal planar shape is 120 degree. So sp3 hybridization and sp2. In sp3 hybridization, one s orbital hybridized with 3 p orbitals, giving rise of 4 sp3 hybridized orbitals, and the bond angle and the shape for sp3 hybridization is tetrahedral, and the bond angle for tetrahedral shape is 109 degree 28 minute. And if one s orbitals hybridized with 2 p orbitals, then the state of hybridization is sp2, and for sp2 the shape will be trigonal planar, this one, and the bond angle for sp2 hybridization is 120 degree. Now we will see how sp hybridization occurs. Okay, so today we are having a lecture on chemical bonding. In chemical bonding, the subtopic is hybridization. Now, what is hybridization? We have said earlier that hybridization is nothing but a mixing of orbitals in which unpaired electrons or valence electrons are present in the, of course, valence shell or outermost shell of the central atom. Just the mixing of orbitals is called hybridization. Now, before the concept of hybridization, we have already seen that when methane molecule is formed, in methane carbon has 4 unpaired electrons, and those unpaired electrons are present in s orbitals, in 1 s orbitals and 3 p orbitals of carbon. And for methane, other 4 hydrogen comes with 1s electron, unpaired electron in their valence shell. Now, if the overlapping occurs between the orbitals, then for methane there will be one ss orbital, ss overlapping, which is between the 1s orbital, 2s orbital of carbon and 1s orbital of hydrogen, and the other 3 bonds will be formed by the overlapping of p orbitals, 3 p orbitals of carbon, 2 p orbitals of carbon, and of course the 1s orbitals of each 3 hydrogen atoms. So there must be one in all CH, 4 CH bonds of methane. One is formed between between the overlapping of 2 s orbitals, and the other 3 bonds are formed due to the result of overlapping between s orbital of hydrogen and p orbitals of carbon. Now, we have already seen that the extent of overlapping is not same in everywhere. In SS overlapping, the extent of overlapping is very poor because those orbitals are spherically symmetrical. So they not come, their electrons are very near to each other. So mixing, the extent of overlapping is less. In SP overlapping, the extent of overlapping is more. So in methane, if there is one ss orbital, one bond is formed between 2 s orbitals, overlapping of 2 s orbitals, and the other 3 bonds are formed between overlapping of s orbital and p orbital. Since in extent of overlapping is more in s and p orbital, then what happens, the resultant bonds will be stronger in case of sp overlapping and weaker in case of ss overlapping. Therefore, we should not have equal bond energy in all CH bonds of methane, but actually it was seen that all the CH, 4 CH bonds of methane are energetically equivalent. And what was the explanation? Then it was said that before overlapping, a hybridization or mixing of orbitals of the central atom occurs. So the first step for the formation of a covalent molecule, the first step is the rearrangement which occurs in the outermost shell of the central atom, giving rise of necessary number of unpaired electrons. Okay, after that a mixing occurs among the orbitals in which the unpaired electrons are present, and that mixing is called hybridization. And then those hybridized orbitals expose themselves around the central atom in a definite manner depending upon the state of hybridization. Now, we have already seen what happens in case of sp3 hybridization, sp2 hybridization. Now, we will see how sp hybridization occurs. sp. Okay, now one molecule which is having sp hybridization is acetylene, CH, then triple bond, then C, then H. Each carbon is here sp hybridized. How can we see? How can we say? In carbon, the electronic configuration is again 2s2 and 2p2. Now, the rearrangement occurs where an electron jumps from 2s orbital to 2p orbital, giving rise of 4 unpaired electrons in the outermost shell. Okay. Now, among these 4 orbitals where unpaired electrons are present, 2 orbitals are hybridized, one s orbital and one p orbital. So, the state of hybridization will be where one part of s and one part of p is present. The state of hybridization is sp. And how many sp hybridized orbitals will be there? Only 2 sp hybridized orbitals will be there. Okay. Now, for the sp hybridization, the shape is linear. The shape is linear. Now, if the shape is linear, the bond angle is the bond angle is 180 degree. Okay. Now, how those sp hybridized orbitals expose themselves around the central atom carbon? Of course, in a linear manner. Okay. So, two sp hybridized orbitals for this carbon, for each carbon, two sp hybridized orbitals here, and this, for this carbon, one sp hybridized orbital overlaps with the sp hybridized orbital of other carbon, and other sp hybridized orbitals actually overlap with hydrogen atom. So all are sigma bonds. In sigma bonding, hybridized orbitals take part only in sigma bonding. Okay. So here the sigma bonds are formed. Now after formation of this, still py and pz orbitals remain in unhybridized state. Now if the bond axis is x-axis, then hybridized, then unhybridized orbitals like py and pz are perpendicular with this. Now since py is parallel to the py orbital of other carbon atom, here lateral overlapping occurs, and here also lateral overlapping occurs, and that is how two pi orbitals are formed. Okay. So this is how acetylene molecule is formed. Here the state of hybridization of carbon is sp hybridized, and this shape is linear, the bond angle is 180 degree, and this is how acetylene molecule is formed. So we have seen sp3 hybridization, sp2 hybridization, and now it is sp hybridization. Now we will see how sp3d hybridization occurs. Okay, let's see. sp3d state of hybridization. Let us consider a molecule PCl5, phosphorus pentachloride, where the central atom is phosphorus having atomic number 15. The electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p3. The outermost shell or the valence shell is third shell, and all the electrons present in the outermost shell or valence shell are called valence electrons. So the valence shell configuration is 3s orbital जहाँ पर 2 इलेक्ट्रॉन होता है, और 3p orbital where 3 electrons are present and they must be unpaired. Okay. Now यहाँ पर phosphorus pentachloride has already made 5 covalent bonds. Only unpaired electrons can form covalent bonds. Since this is already formed, so 5 unpaired electrons must be there at the outermost shell of phosphorus, but we can see only 3 unpaired electrons are present. Now where the 2 unpaired electrons come, like the other 2 unpaired electrons come from this 3s orbital. Okay, since third shell has also 3d orbital, so here phosphorus is also vacant 3d orbital, where electron 1 2 3 4 5 d orbitals कितना होता है 5 होता है. तो यहाँ पर जो excitation होगा वहाँ पर एक इलेक्ट्रॉन from 3s orbital will jump to the 3d orbital. Okay, so in the rearrangement 3s orbital will have only 1 electron, 3p orbital will have 3 unpaired electrons, and 3d orbitals will have only 1 unpaired electron. Okay, our total number of unpaired electrons now here is 5. Okay, so this is the rearrangement that takes place at the outermost shell of the central atom phosphorus. Now what happens? Now hybridization will occur. Now here hybridization occurs between one s orbital, 3 p orbitals, and 1 d orbital. So the state of hybridization will be s, p3 and d. So the state of hybridization is sp3d. Due to this state of hybridization, the shape will be trigonal bipyramidal. Okay, so how trigonal bipyramidal shape is formed? Here is phosphorus, 3 orbitals, 3 sp3d hybridized orbitals will be in a same plane, in a trigonal planar shape. Okay, these are 3 sp3d hybridized orbitals, and the other 2 sp3 hybridized orbitals will be above the plane and below the plane. Okay, so here Cl, 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 Cl. This is the shape of PCl5 molecules. Now यहाँ पर इसको अगर आप जोड़ दो तो यहाँ पर एक पिरामिड आएगा, और नीचे अगर जोड़ दो तो नीचे भी एक पिरामिड ही आएगा. तो दैट इज़ वाई दिस इज कॉल्ड अ ट्राइगोनल बाइपिरामिडल शेप. ऊपर एक पिरामिड होता है और नीचे भी एक पिरामिड होता है, तो इसलिए ये बाइपिरामिडल है, और यहाँ पर बीच में एक ट्राइगोन प्रेजेंट है. दैट इज़ वाई द मॉलिक्यूल, द शेप इज कॉल्ड trigonal bipyramidal shape. So in case of PCl5, in case of sp3d hybridization, the shape is trigonal bipyramidal. And what will be the bond angle? The bond angle in the trigonal planar, यहाँ पर जो shape है वहाँ पर तो bond angle each PCl, यहाँ पर Cl PCl, ये bond angle तो 120 डिग्री होगा, और जो above the plane है वो तो 90 डिग्री में है, और जो below the plane है वो भी 90 डिग्री में ही है. So this is sp3d hybridization. Now we will see what is sp3d2 hybridization. Okay. Or these bonds which are present in trigonal planar, ये shape में जो bonds होता है इसको equatorial bonds कहते हैं, equatorial bonds. And these bonds which are present above and below the plane of the trigon is called, or are called, above the plane and below the plane में जो bond रहते हैं उसको कहते हैं axial bonds. Okay, so there are 3 equatorial bonds in PCl5 molecule. There are 3 equatorial bonds and 2 axial bonds which are present above and below the plane of the trigon. Okay. Now sp3d2, let us consider the molecule sulfur hexafluoride SF6. So in sulfur has the atomic number of 16. So the electronic configuration is 1s2, 2s2, 2p6, then 3s2, then 3p4. This is the electronic configuration of sulfur. Now the outermost shell is third shell. In third shell, the electrons present are a paired electrons present in 3s orbital, and in p orbitals, 3p orbitals, 4 electrons are present. 1, 2, 3 and 4. Now since this is third shell, 3d orbitals must be there, which is totally vacant. So rearrangement occurs where electron jumps from 3p to 3d and again from 3s to 3d. तो यहाँ पर से एक इलेक्ट्रॉन अगर जाएगा तो यहाँ पर एक अनपेयर्ड इलेक्ट्रॉन आता है, और यहाँ से एक इलेक्ट्रॉन जाता है 3d में. तो now the total number of unpaired electrons in the outermost shell of sulfur is 1, 2, 3, 4, 5, 6. Total number of unpaired electrons is 6, and here sulfur, in sulfur hexafluoride, sulfur has already made 6 covalent bonds. So hybridization occurs between all of these 6 orbitals, where one s orbital is present, 3p orbitals and 2d orbitals. So the state of hybridization is sp3d2. Now due to the state of hybridization of sp3d2, the shape is octahedral. Now how octahedral shape is formed. Central atom is sulfur. All 4 SF bonds are present in the same plane, that is a square planar, in a square planar shape. One SF bond is present above the plane and the other is present below the plane. Okay. Now we draw this. Before I outline this, then यहाँ पर एक टेट्राहाइड्रल होता है और नीचे भी एक टेट्राहाइड्रल होता है, तो दोनों मिला के octahedral. So this is the octahedral shape of sulfur hexafluoride, where all the bonds, all the bond angles are 90 degree. Okay, so in sulfur hexafluoride, all the bond angles are 90 degree. So we have already we have discussed today the hybridization, the state of hybridization sp, sp2, sp3, then sp3d, then sp3d2. In my next class, I will discuss with some other molecules with different hybridization and with some example, with some questions on it. Okay, good night.